Alrighty, welcome friends to homework 2.1. We're going to be doing the exercises. The exercises for this section are page 77, 1 through 13, 19, 21, 27, 31, and 37 odd. I'm going to be working through 5 of these, number 3, 7, 9, 19, and 37. So here's some examples of us using, again, inductive reasoning, which is drawing conclusions based on patterns. So question number 3 is just practicing using inductive reasoning. We've got some what look like fractions here: 1/3, 2/4, 3/5. What would come next? It says we need to find just the next term. It looks like the top, they're basically increasing by 1. I see a difference of 1 here, a difference of 1 here, plus 1, plus 1. Down here, same thing, plus 1, and here, plus 1. So I would imagine the next term would be 1 more than 3, which is 4, and 1 more than 5, which is 6. We could give another term, which would come next, would be 5, 7, but it only asks us for the next term, so we will leave it at that. So again, when we do that, when we look at patterns and we draw conclusions, we're using something called inductive reasoning. Okay, number 7, I wanted to do this one because it's also establishing a pattern, but maybe a little trickier. Number 7, it reads, a laboratory culture consists of 150 bacteria. After 20 minutes, the culture contains 300 bacteria. After 1 hour, the culture contains 1,200 bacteria. Make a conjecture about the rate at which the bacteria increases. So they want us to observe a pattern and try to come up with a rule or come up with a statement, that a conclusion of what's happening. What is the rate at which the bacteria is doubling? So let's put some of their information down. So they mentioned that at 0.0, so at the beginning, we're going to call that 0. There were 150 bacteria. And then at 20 minutes later, plus 20 minutes, there were 300 bacteria. Okay, and then it jumps ahead and says to an hour later. So an hour later. So that is how many minutes from 0? Well, an hour later, that would be another 20 minutes, and another 20 minutes, 20, 40, 60. So it says an hour later, then there are 1,200 bacteria. And so we can kind of study this pattern and take a look at it, because again, an hour is right here. We can see that the time that passed here was 1 hour, or 60 minutes. So you could look at this pattern and say, well, what was it here? So you had at 0 minutes, there was 150. At 20 minutes later, there were 300. 20 minutes later, or 40 minutes later, we can conjecture, well, there was probably 600. And then 20 minutes after that, which brought it to a total hour, there were 1,200. So we can see it's doubling, 150 to 300 to 600 to 1,200. We could even extend it and say in another hour and 20 minutes, there would be 2,400. Okay, so that's the pattern that we can uncover here. So again, the question is, what's the rate of increasing? Well, you could say it's doubling. Looks like it is doubling. We got enough. Yeah, we got right space right here. The bacteria. I'm going to switch colors. Bacteria is doubling every 20 minutes. That's some feisty bacteria. Okay, and this is a chapter definitely where it's up to you, but if it's a little too cumbersome to box things, I understand. I'm going to go ahead and box that since I had so much other work done. I wanted to show my answer, but you can use a little bit of discernment. So you might not be able to box all your responses in chapter 2 because they can be lengthy. All right, let's take a look at number 9 then. Notice then again that a conjecture is the statement or the conclusion you can draw from a pattern. Number 9, it says show that each conjecture is false by providing a counterexample. So we need to prove that conjecture false. Number 9 says 3 points on a plane always form a triangle. Okay, so it's saying if I take 3 points, then those things form a triangle. Well, yeah, that looks pretty good. If I do another 3 points, random spots, yeah. So this one looks pretty good. Now the instructions have told me not to decide if it's true, but to find the counterexample. So there must be a way in which 3 points don't form a triangle. And if you watch the notes video, you already know the answer to this. And that is, what if the 3 points are in a line? What if they are collinear? If I do 3 points that way, if I connect them, That's not a triangle. In fact, we just get a segment. Okay, so that would be our counterexample. 3 collinear points. An exception to the rule, which then that means that that conjecture is false. It's not true because it's not true in all cases. And that's what a counterexample does. All righty, let's take a look at number 19. Just trying to give you a sampling of the types of questions you'll see in these exercises. It's another one. It's show that conjecture is false by finding a counterexample. And again, you might find these tricky just because you might feel unfamiliar with what they're asking, but I just encourage you to, like I did in the one above, just experiment with what they say and see if you can uncover when it's not true. So number 19 says, every pair of supplementary angles includes one obtuse angle. So notice now, if you don't know your vocab from chapter 1, this kind of gets a little hairy, a little difficult. But luckily, I know my vocab. How about you? Okay, supplementary angles have to add up to 180. So there's like an angle here, there's the 180, and then there's 2 angles that are supplementary. And so what this is saying that is whenever you have these supplementary angles, one of these must always be obtuse, which if you remember is greater than 90 degrees. So you can see in that case, here's an obtuse angle. If I could do it another way, whoops, let me erase that. If I do it another version like that, well, no, now I've got it. There's an obtuse angle, so that works. And so you kind of start envisioning, is there any case where I could make it so that it forms a straight line and you don't have an obtuse angle? You might think, no, always one's going to be acute and one is going to be obtuse. But maybe you've hit it. There is an exception to that. What if it looks like this? Okay, therefore, those are supplementary angles. They add up to 180, but that is not greater than 90 degrees. In fact, they are both 90 degrees. And by definition, a 90-degree angle is not obtuse. It is a right. These are right angles. So the counterexample would be 2 right angles. And I would abbreviate angles like that. Okay, so both my drawing and my little statement there are ways of providing a counterexample to disprove that conjecture on 19, that 2 supplementary angles always include an obtuse angle. Nope, not if they're both 90. It could be 2 right angles. Neither of those are obtuse. So a little tricky, kind of fun though, to try to find the flaw in the statement or the conjecture. All right, last one. We'll just do 37 with you. Let's see, I think 37 is a multiple choice. And again, it's which of the following conjectures is false? And so they give us 4 conjectures, and you really just kind of have to read them and look for the one that you think you can disprove. 3 of them, we're not going to be able to disprove. 1 of them is false, so there must be a counterexample. So A says, if x is odd, then x plus 1 is even. X is odd, then the next number, x plus 1, must be even. So in other words, if I go 1 more than 3, then I have to have an even number. Or if it's 7, if I go 1 more number, then I would have to go 8. That's even. If I go, let's go negative. Negative 3. And I add 1 to that, I'm going to get negative 2. That's also even. I want to take a break from A. A looks pretty good. Let's take a look at B. B says the sum of 2 odd numbers is always even. All right, well, let's do a pattern and use our inductive reasoning. The sum of 2 odd numbers. Let's see, 3 plus 5 is 8. That's even. 1 plus 9 is 10. That's even. 7 plus 9 is 16. That's even. Okay, I'm not sure I like where this is headed. So let's go ahead and take a look at C. C, light blue, why not? All right, C. C says the difference of 2 even numbers is positive. The difference of 2 even numbers is positive. So like 4 minus 2 is 2, that's positive. 10 minus 8 equals also 2, that's positive. 2 even numbers. How about 2 minus 4? That's negative 2. And those numbers are both even, and yet the answer is not positive. So there we go. I can subtract these two. And if I subtract this bigger one from the smaller one, I can get a non-positive number. And I'm still doing it. So that is my counterexample. Looks like C, a super circle, C is the true one. And I'm just going to only assume that D is probably also true. If X is positive, then negative X is negative. Well, that seems pretty good. Might as well just shove it in the pattern. D. Oop, that's a little hard to see. Maybe yellow's not going to work. We'll go orange. All right, D. If X is positive, so 2 is positive, negative 2 is negative. Yep. 4, negative 4 is negative. Okay, this one seems pretty true. It has to be positive, so I can't start negative. So 10, and then if I add a negative, it's definitely going to be a negative. Okay, so yep, I'm going to go with C. Number 3, C is the one that I can disprove, because if I subtract a bigger number from a smaller number, even though they're both even, I can get a negative answer. So a little bit of thinking, and not a lot of arithmetic, but you're just using your reasoning and establishing patterns. And so have a good time and reach out if you're confused or need help. All right, good luck.